In this video, we're going to do some more examples of trigonometric equations. I have these three examples here. Let's look at this first example. We know that in a trigonometric equation, there must be only one type of trigonometric function. But over here, I have these two types of trigonometric functions. I have a sine function and a cosine function. So how are we going to solve this problem? I can only have one type of trigonometric function in a trigonometric equation because there's a equal to sign over here. Well, what I can do over here is that since these two terms are factorized, I can equate each factor equals to 0 like we do in algebra. So this is going to be sine x is equal to 0, and the other factor 1 minus 2 cosine x, that's also going to be equal to 0. Now I have two trigonometric equations and I'm going to solve both of these trigonometric equations separately and then combine the answers at the end to get the final answer that's going to be the solution of this question. So for this first example, I have sine x is equal to 0. We learned in the previous video that if we have is equal to 0, 1 or minus 1, the quicker way to solve the question would be use the graph. So if I draw the graph of sine x of the sine function, this graph is at 0 at these 3 points. So the answer to this equation would be x is equal to 0. This point is 180, so 180, and this is 360, so 360 over here. So this is the answer to this equation, sine x is equal to 0. Now the second equation, 1 minus 2 cosine x is equal to 0. If I separate out cosine x, I'll need to add 2 cosine x on both sides, so this would be 1 is equal to 2 cosine x, and if I divide 2 by both sides, this would be cosine x is equal to 1 upon 2. Now for an equation of this type, I'll use the quadrant rule. My first step would be to replace x by my reference angle, which is alpha, so cosine of alpha is equal to 1 upon 2. And to separate out alpha, I'll send cosine on the other side, so alpha is equal to cosine inverse of 1 upon 2, and if I use a calculator, cosine inverse of 1 upon 2 comes out to be 60 degrees. So my alpha, the reference angle, is equal to 60 degrees. And if I draw my 4 quadrants over here, cosine x is equal to 1 upon 2 means my cosine function is positive, and cosine function is positive in these 2 quadrants, in the first quadrant and in the fourth quadrant. And my reference angle is going to be this alpha and this alpha. And if I measure my angles, my first angle is going to be measured from over here, and my second angle is going to be measured from this point again up to here. Since alpha is 60 degrees, 60 here, 60 here, so my first value of x is going to be 60 degrees, this angle, and my second angle, this angle, is 60 degrees short of 360 degrees. So it's going to be 360 minus 60, which is equal to 300 degrees. So these are my two answers for this equation. So for my original question, this equation, the answer is going to be the combination of both. So I'm going to combine both of these answers, and I'm going to write my answers in ascending form. So my first angle is going to be 0 degrees, this 0, and my second angle is going to be this 60 because 60 is smaller than 180, and because I'm writing in ascending form, I'll write smaller to bigger. So the second is going to be 60, the third is going to be 180, the fourth is going to be 300, and my final angle is going to be 360 degrees. So this is the answer to this equation. Let's look at the second example. Over here, I have 2 sine x cosine x plus cosine square x is equal to 0. And again over here, I have two types of trigonometric functions. I have a sine function and a cosine function. So what I can do over here, either to convert them into one single trigonometric function, which I cannot in this case, or either I can factorize. So if I factorize, notice in the first term I have a cosine function, and in the second term I also have a cosine function. So I can take cosine function as common. So if I take cosine as common, I'll get 2 sine x plus cosine x is equal to 0. And this is now factorized. So I can equate cosine x is equal to 0 and write 2 sine x plus cosine x is equal to 0. For this first equation, cosine x is equal to 0, I can draw a graph. The graph of cosine x looks like this, and cosine x is 0 at these 2 points. This point is 90 and this point is 270. You need to remember the graphs. So the value of x for this equation is 90 and 270. These are the answers for this equation, cosine x is equal to 0. Let's look at the second equation. 2 sine x cosine x is equal to 0. Now in this equation again I have two trigonometric functions and I cannot factorize this equation again. But what I can do over here, I can convert both of these into a single trigonometric function. Whenever we have two types of trigonometric function, either I can factorize or I can convert them into a single trigonometric function. And if I divide both sides of the equation by cosine x, cosine x, cosine x and cosine x. I divided both sides of the equation by cosine x. This cosine x and this cosine x would cancel out to become 1, and 0 divided by anything is just 0. So here I will get 2 plus 1 is equal to 0, and sine x divided by cosine x we know is tangent of x. So this equation becomes 2 tan x plus 1 is equal to 0. Now I only have one trigonometric function, so now I can solve this equation. To separate out tan x, I'll send 1 on that side. That gives me 2 tan x is equal to minus 1. And if I divide both sides by 2, I will get tan x is equal to minus 1 upon 2. Next step, I'll replace x by my reference angle, which is alpha. So tan alpha is equal to minus 1 upon 2. And if I use a calculator, tan inverse of minus 1 upon 2 is equal to minus 26.56. So alpha is equal to minus 26.56. I can round off to one decimal place, so minus 26.6 degrees. And if I draw my four quadrants, over here tan x is equal to minus 1 upon 2. So tan x is equal to a negative number. And the tan function is negative in these two quadrants, in the second quadrant and in the fourth quadrant. So I will get a line in this quadrant and in this quadrant. Remember, the reference angle is always measured from the x-axis. So alpha here and alpha here. The value of the reference angle is minus 26.6. But for reference angle, we always take the magnitude. I'm not concerned with the direction. So I'll just write 26.6 here and 26.6 here. Now if I measure my angles from 0 degrees, my first value of x is going to be this, and my second value of x is going to be this. So the first value of x is going to be 180 minus 26.6, and the second value, this green angle, is going to be 360 minus 26.6. So the two values that I get are 153.4 and 333.4 degrees. So this is my answer for this equation over here. And for the final answer of this equation, I'll combine my answer of this factor and of this factor. So my final answer is going to be 90 degrees, this 90 degrees, and the next angle is going to be 153.4 because I'm writing my answers in ascending form. So 153.4, the next is going to be this 270, and my final angle is going to be 333.4 degrees. So this is my answer for this second question. Let's look at this final example. Over here I have 2 tan square x minus tan x is equal to 6. The conditions to solve trigonometric equation are that I need to have only one type of a trigonometric function, and over here I have only one type of trigonometric function, that is tan x. But the other condition to solve trigonometric equations is that there should be only one trigonometric function is equal to some constant value, and over here I have two tan functions. So what I can do over here is that either I can convert both of these two to combine to make a single trigonometric function, or either I can use factorization. And even if I divide both sides of the equation by tan, This tan would cancel out, but a tan would come over here. So I cannot combine these two to make a single trigonometric function. So what I can do over here, I can factorize these two. If I subtract both sides of the equation by 6, I would get 2 tan square x minus tan x minus 6 is equal to 0. Now if I consider tan x as a variable, I can break the middle term to factorize this. This is a type of a quadratic equation. So to break the middle term, I can write 2 tan square x minus 4 tan x plus 3 tan x minus 6 is equal to 0. And in the first two terms, if I take 2 tan x common, I'll get tan x minus 2. And in the last two terms, if I take 3 common, so plus 3, I'll get tan x minus 2. These two brackets are the same, means I have factorized correctly. So the two factors that I get are tan x minus 2 and 2 tan x plus 3 equals to 0. To solve this, I'll need to make some space over here, so I'll just erase the solution of the previous questions. So this would give me the first equation tan x minus 2 is equal to 0, and the second equation 2 tan x plus 3 is equal to 0. To solve this equation, this would become tan x is equal to 2, and this would become tan x is equal to minus 3 upon 2. Now let's solve these two equations. For the first equation, tan x is equal to 2. If I replace x by alpha, my reference angle, this would be tan alpha is equal to 2, and to find the reference angle, I'll send tan to the other side. So this becomes alpha is equal to tan inverse of 2. And if I use the calculator to find the reference angle, this comes out to be 63.43. And if I round off to one decimal place, this would be 63.4 degrees. This equation over here for the angle of x has a positive value. So my tan function is positive. So if I draw my four quadrants, because tan function is positive, my two lines, the first line would be in this quadrant and the second line would be in this quadrant. Remember, the reference angle is always measured from the x-axis. So this is alpha and this is alpha. 63.4 here and 63.4 here. The angles x are going to be, this is going to be the first angle and this is going to be the second angle. I'm measuring anti-clockwise because I need positive angles. This is my domain. So my first angle is going to be 63.4, this angle, and my second angle is going to be 180 plus 63.4, which is equal to 243.4. So x is equal to 63.4 and 243.4 degrees. This is the answer for this part of the equation. Now for the second equation, tan x is equal to minus 3 upon 2. If I draw my four quadrants, over here the tan function is negative, and that's in these two quadrants. So I'll draw a line here and a line here. The reference angle is always measured from the x-axis. So this is going to be the first and this is going to be the second reference angle. To find the reference angle, I'm going to replace x by alpha. So tan alpha is equal to minus 3 upon 2. Alpha is equal to tan inverse of minus 3 upon 2. And if I use the calculator to find tan inverse of minus 3 upon 2, I'll get minus 56.3. So alpha is equal to minus 56.3 degrees. This is the reference angle. And that means that from 0 degrees, the reference angle is clockwise minus 56.3 degrees. But the reference angle we always write as positive because we are only concerned with the angle, not the direction. So I'll write 56.3 here and 56.3 here. And my angles theta, this is going to be my first angle and this is going to be my second angle. This first red angle is going to be 180 minus 56.3 and that is 123.7. So x is equal to 123.7 and this green angle is 360 minus 56.3. So 360 minus 56.3 is equal to 303.7. This is the second angle. So this is the answer for this part of the equation. But for the final answer, the answer of this question, I'll combine both of these answers. So my final answer is going to be in ascending form, this first angle 63.4 degrees, this second angle 123.7 degrees, this angle 243.4 degrees, 243.4 degrees, and this angle 303.7 degrees. This is my answer for this third question.